let's start. Just do a quick recap of what we have covered so far. So we explained different clauses, SQL clauses, and mainly focusing on select, distinct, and what is their difference, and why actually we do use select is actually mainly to identify which column you want to see in your result, right? That is what you specify in your select part of the statement. So for example, if you have a student table with like many columns, including, let's say, a student ID, name, and so on, if you want to just see these two columns, a student ID and name, then you write select a student ID, student name, right? So that is about the select. And then we said sometimes we have repeated results, but you're only interested in just one distinct value. And in that case, you select distinct. For example, let's say you have different roles in your department, but we have like hundreds of employees, but with only like, let's say, 3 or 4 roles. And then you don't want to like see all these 200 rows, right? And repeating their role, but you only want to see what is the distinct, for example, roles that you have in your department, and then you use select distinct. Then we talked about the order by. So we said if you want to like just order the results of your query, you can use order by. And so just an example of an order by. Here I showed you with different columns. Like for example, in the staff table, if you want to select 2 columns and then order by department number, for instance, or maybe you, and also I said if you don't specify anything, the order is ascending. If you want to like see in descending order, you just specify that. You have to explicitly write. And then not always you want to just order by 1 column. Sometimes you want to order by 2 columns, for example. In that case, I mentioned if you don't write anything, it assumes like both columns should be ordered in ascending order. And for any of them, if you want to like see them in descending, you have to specify. Just one point here. If you write, for example, select department number, staff name from staff, order by department number, staff name, descending. So the result, if you see, it shows you like department number is still in ascending order, right? And the only thing that changes is that within each department, then the staff name is ordered in descending manner, okay? So that was the difference. And so here is another example. For example, the first query, return department number as staff name, and it sorts the data based on department number ascending, right? And then the staff name descending, which means that you will see department number from D15 to D42, and then within like each department, for example, D20, how do you know you have to have D20 standards, for example, before Pernal? Because you specified here that staff name should be descending, okay? And the same here, again, you select the second query that you see the result here, is still selected, same 2 columns, order by both columns descending, which means this time is start department number from D20 42, and then within each still have the descending order, like a staff name ordered in descending manner. And here just some more examples that we have seen. So we said also we can use order by to, for example, find top n values of a specific column. For example, if you want to see like the staff with highest salary, like let's say top 3, then you can use select top and then specify the number. Like for example, if it's top 3, then top 3 from the staff table, and then order by the column that you want to see the result of top, right? For example, top 3 salaries, so you order by salary. Now, here I mentioned if you are not using SQL Server, if you are using MySQL, SQLite, then you have to use limit. Then if you use top, it doesn't work. And this is the way that you write it. Just some predicates for the where condition that I ask you to practice, like with different arithmetic comparison operators, Boolean operators, and so on. Here are just some examples for your own practice. And we also explained group by. So if you want to like group the rows of your data based on sharing the same values in one or more column. So what does that mean? Most of the time when you are using aggregated functions, like for example, if you want to count something, get average, minimum, maximum for like for example, several fields, several rows, then you can use aggregated functions with group by. This is an example query, for example, finding number of employees. As soon as you see number of employees, you know that you have to use count, right? So that is count star because we are working on the staff table. A staff table includes all the employees. So when you write count star means count of all the employees, right? Because the employees in the staff table is just distinct. Now you group by department number. Why? Because you want to find these average, minimum, maximum for each department. That is why you have to group your rows of your data into one row. For example, for department D15, you get one average. For department D20, you get one average, right? So you cannot have like repeated values. That's why you group by department number. And one important note here is that whenever you're using group by, you cannot have any column in the select part of your statement. So your select statement is limited to only the columns that you use in the group by, or if they are coming with the aggregated functions. So for example, here you could use department number. Why? Because it is already used in the group by, right? So you group by department number. We are sure that we don't have any department number repeated. And also count, average, minimum, maximum, they're all valid because if you're, for example, getting, for example, average, minimum, count, it returns only one value, right? So we can get it for each department. And here is just the implementation, and then different examples for aggregate functions. For example, finding how many different jobs exist in the company you use. Because you want to find distinct or different jobs, that's why we use distinct job, and to count it, we use the count aggregate functions. The second one was an example of nested query, just a very simple one. We said in order to find whose salary is above company's average, first of all, we have to find company's average salary, right? And that is this like query here. And then we find which are the staff, select the staff whose salary is greater than this amount, which is the company's average. And here's another note. You cannot use aggregated functions directly in the where clause, meaning that this query doesn't work, okay? So you cannot just write select staff name salary from a staff where salary is greater than average salary. We have to identify where we are selecting it from, right? So this is not correct, and aggregate functions can only appear either within the select clause like we had before. For example, you use select average salary from a staff. That is fine because you're using it in the select statement. Or if you are using the having clause, which we'll see examples in the next few slides. So this one is not correct. And then here was just another example, and just a formal format to write, for example, your group by statement. For example, you select or select distinct the columns that you want to group by, and you can also use any other column as long as they are within the aggregate functions, like, right? For example, if you are grouping by department number here, you are only allowed to select department number plus any other column as long as they are in the, for example, average, minimum, maximum, or other aggregate functions. For example, I can write select department number, average salary, maximum commission, or anything like that, but I'm not allowed to write, for example, select salary department number, because salary is not specified in the group by, and salary alone is not specified with any aggregated functions. So we also had, we also provided this example, which shows that, for example, you cannot select any column that you want when you're using group by. I also explained why, so I think we don't need to explain it again. So the main reason is that when you're using aggregated functions, you know that which value you have to provide for the B column here or X column here. But if you don't know what you have to provide. So for instance, if you write select A and B from table T group by A, it means your output should have only one row for A equal to 1, one row for A equal to 2, right? So you know what you have to specify in the A column of the result, because that is the column that you are grouping data by, right? But you don't know what you have to write for B then. So should you write, for example, here in your result, if you're grouping by A, meaning that you're grouping your rows of data, right? So it means that you have 1 and 2 for A, and then what do you want to write for B? But if you write, for example, average B, then we know, for example, we have to get average of this for A equal to 1. If it is maximum, minimum, is still valid, right? Because we know which value we have to provide. Otherwise, this is not correct, and you will get an error. And then we explained the having clause. We said that sometimes after using the group by, we want to further filter the results. So, for example, if you, let me explain this first and then explain the example. And as I mentioned before, if you're using having, then you are allowed to use the aggregated functions with having, right? We said aggregate functions either in the select part of the group by, or if you're the having part. And I'm also going to explain what is the difference between having and where, just to review. Let's first see these two examples. Finding, for example, average salary for each department with more than 2 employees. So up to here, finding average salary for each department, we learned that, right? Using group by. We just write, select, for example, department number and average salary from the staff table, group by department number, so that we can get the average salary for each department. So we select these two columns, and then we group by department number, right? So far, we got average salary for each department. But after we group by our data, now we still need more condition, right? So we need only those departments with more than 2 employees, okay? So this is when you use having and not where. So you cannot write where count of, for example, employees or count star is equal to 2. And I hope you understand why, because this is after the aggregation. So this is applied to the result of the group by. And so you have to use having, okay? So having count star greater than 2 means only those departments whose number of employees is greater than 2. Is this clear? Okay. So next example, finding department with average salary higher than company's average. Again, I emphasize on differentiating this query with the one that asking you finding the staff or employees with average salary greater than company's average. Like the two queries are very similar, but like they look similar, but the way that you answer them or the SQL statement is very different. So if you want to find staff with salary greater than average salary, because in the staff column, each row of the staff table is corresponding to a unique employee, right? You don't need to use group by there, like for the staff, right? I will show you later. I don't want to like exit the PowerPoint now. So in that case, you didn't use like any having, or like you didn't need to do what we do here. So we only write, for example, select department number, average salary from staff, group by department number. So up to this part, we get the average salary for each department, right? Now, we want to find out which departments have average salary greater than the company's average. So again, you have to check what is company's average, right? What is company's average salary? You have to use like select average salary from a staff. That query gives you the average salary in the staff table, which shows the average salary of the company. So that is this part, okay? Now we want to find departments that their average salary is greater than this amount. Now, the problem here, or the difference here with the other query that we have seen before, is that in the staff table, which we are selecting our columns here, so in the staff table, the departments were repeated, right? So let me show you the tables. This is so far. I didn't expect to go back this much. Okay, so just to show you the tables. So if you see the staff table, now each row corresponds to a unique staff. So if you want to find the employees with average salary greater than company's average salary, you only need to find first company's average salary, which was our nested query, select average salary from staff, and then you select, for example, staff, for example, name or staff ID, where you were using where, right? Where, for example, salary, which is corresponding to each staff salary, is greater than that nested query, which gives us the average salary for the company, right? We didn't use any group by in that case or having. But if you want to find for the departments, now if you see we have several D20 here, right? So we have to group by department number to find the average salary for each department, and then do the comparison with the average salary of the company. So keep in mind this, keep this table in your mind. So with the columns that it has, so because the department number was not unique here, we had to use the group by. So this is the difference, right? This was for the employees whose salary was greater than company's average. We didn't use any group by, right? Because in the staff table, they are already grouped by. They are like each row correspond to a unique employee. So we didn't need to like group by employees. But here, if you want to find this information like departments with average salary higher than company's average, because the salary is provided in the staff table and because the department number is not unique in the staff table, we need to first group by department number and then check our condition. That is, the average salary for each department is greater than this amount. What is this amount? The company's average salary. And do you have any question? Was that clear? When to use group by, when to use where, and when to use having? So having is applied after aggregation, but where can be used like before aggregation. So these are just more examples that we already covered. Now let's start with joins. So I quickly mentioned that sometimes you want to like select data from more than one table. So for example, you may want to like find out, for example, grades for students, for all students, or for like specific students with some conditions. And let's say your student table only contain student information, but not any grade information, right? You only have a student ID, student name, email, phone number, and so on. So in that case, because you want to select from more than one table, so the column that you want to see in your result is selected from more than one table, so we need to join the tables, right? Now, in order to join the tables, we often use the foreign keys, because in the data modeling, if you remember, we mentioned that do you remember how did we link the tables together in the relational diagrams with the foreign keys, right? So most of the time when you want to join tables, you use the foreign keys, but not always. And I provided example of the queries where you may want to join tables based on another common field. Sometimes two tables have more than one common field. Like 90% of the time, most of the time, that common field is the foreign key. sometimes there are also other common fields or attributes in addition to the foreign key. And so the first type or the first way to use join is simply avoid explicitly specifying join and just writing the where, okay, using where clause. Now, for example, let's say you want to select course code, course name, and instructor name for each course. And so course information such as course code and course name are provided in the course table, but we don't have instructor name in the course table. Let's say we may have only instructor ID, but not instructor name. In that case, we need to use join, right? Because now we need course table and instructor table. So you already know what you have to write in the select part. We said select is used only to specify which column you want to get, right? Some of you look at me really angry. What is happening? Everything okay? Midterms going well? Okay. So you want to select course code, course name, instructor name, right? From course and instructor table, because we are selecting from these two tables. And I specified, for example, course as C, instructor as I, and the reason is because when I want to write, for example, the where clause to join the two tables, it's just easier to write C.instructor ID instead of course.instructor ID, right? It's just shorter, but you're free to not using any alias. You can just remove this as part, and then just write where course.instructor ID is equal to instructor.instructor ID. And instructor ID is the foreign key here. So this is an example of joining two tables using the foreign key. And you can, of course, always use order by if you want to like sort the results of your query based on a specific column. And so we can actually create the tables if you have not done already. And I think I've shared them with you on eClass. So if you just go to course, so that you can practice with me, right? Go to module 6 here, and let me upload the updated one. And then I would like you to create the student, course, instructor, and enrollment table and insert data into it. Just copy paste my SQL commands to create the tables and insert data so that we can practice together, okay? And let me know if you have any problem. So this one should be the correct one. Yeah. So this is the updated one. I'm just going to update this. Let me just delete this and then add it from the beginning. Wow, my God. Okay. This is just go to eClass. Under the Learn tab, you should be able to find this Create Insert the Student, which is for the other example that we may use, for example, for the joins. And for the other one, I assume that you already created a staff and organization tables, just to practice, right? And now, give you like a couple of minutes to just copy and paste like this, and please do it in order. First, create the instructor table because it doesn't have any foreign key, then create a student, and then create course and enrollment. And just one more thing, when you're creating tables, if you remember when I was explaining specifying primary keys and foreign keys when creating the tables, I said you can create foreign keys, right? Just with writing, for example, foreign key, and then specify the name of the foreign key, and then you also have to use references, which shows reference to which table and which column, right? Now, I have an alternative for you. This is correct, but a better way, if later we want to like add constraints and so on, a better way is that you also add a constraint here. Write constraint here when you want to identify foreign key, and then here is your constraint name. So constraint name, whatever name that you want. Foreign key, the name of the foreign key. References, the table that you're referencing to, and the column you're referencing to, right? So this is the way that you write it. So for example, when you're going to create the table student, you write create table student, the columns specifying whether you allow null or not, identifying primary key. And then for foreign key, what you have learned was this, right? Foreign key, the name of your foreign key, or the column that is foreign key, references which column. Now, I would like you to, I suggest you to use this version, adding constraint, any name that you want to like specify for your constraint, and then writing this. So you can do this also for the enrollment. So I didn't write it here, but of course you can write constraint, any constraint name that you want. For example, constraint foreign key, a student number, ID, anything. And then the rest is the same. The same for this foreign key. So you have constraint. For example, I would like to name my constraint FK underline course code, because then it is more clear for me what it was. And then, which means that it's the foreign key here. So I think this is the better way. And then inserting data. Again, for inserting data, you have to follow the integrity controls that we mentioned, right? You want to like insert data into tables without foreign keys before the ones that have foreign keys, right? Because they are referencing each other. So you have to insert data instructor first, and then into student, then into course, and then into enrollment. And the reason is because you have a column in the enrollment that refers to the course and refers to student, so that you have to create it and insert data into it later. And the same is here. For example, in the course, we have instructor ID, which refers to the instructor table, so that course should be created after the instructor. Now, I assume that you already copied and pasted this and created the tables. Assuming that you have done that, I'm going back here. Now you can try, for example, joining these two tables, course and instructor, to finding the course and instructor name for each course. So if I go back here, I want to show you what each table should look like first. Please tell me I'm not disconnected. I think I'm disconnected again. I wasn't, so it was just slow, but I actually disconnected myself. Okay, so it gives you more time to create the tables if you didn't. So this is a student and course. So you have a student ID, first name, last name, major, advisor ID in the student table. Advisor ID is the same as instructor ID, okay? So this is the foreign key. Then in the course table, you have course code, course description, room, and instructor ID again. So let's see what was the exact name of the tables. So select star from, so this should be correct. Instructor, and then enrollment. Okay, so these are all the 4 tables. For example, enrollment has only 3 columns, a student number, course code, and the grade. And this is the instructor table with instructor information such as instructor ID, first name, last name, and what is his rank, and the course information and the student information. Now, I'd like you to see when I give you a query that I ask you, for example, finding course code, course name, and instructor name, right? Course code and course name are already in the course table, right? This one doesn't have course name, but it seems that I forgot to add it. Let's say we want just course code and course description, or you can just alter table and add a column, right? You can just do that as well. And yeah, I didn't have the course name here. Now, so now back to the example. Asking course code, course, for example, name, which is description here, but that's the same. That actually is the course name, and the instructor name for each course. Now, because the 2 columns, course code and course description, are in the course table, but the instructor is in the instructor, we need to join the tables, right? How can you do it? The first method to do it is just using where. So you can just write, select any column that you want. In this case, we want to select course code, right? So you just write the name of the column that you want to select. And I recommend you always write from which table, because then when you're selecting the columns, it is going to recommend you the correct name. So we want to like select from both course and instructor tables. So we want to select course code or course description and instructor, for example, ID, or maybe, for example, just first name. So it depends on the query, whatever column that you want to retrieve. Let's say we want to get course code, course description, and instructor ID from these 2 tables. Now, instead of using join explicitly, you can just use where to join the 2 tables, okay? You just write where, How do you join the tables? Here using the foreign keys, right? The foreign key is the instructor ID. So if you see, this is the foreign key here, where course instructor ID is equal to instructor ID, right? And then you can always also order by any specific column that you want. Let's say we don't want to do that now. Do I have a typo here? Instructor ID. Okay. Instructor. You're very silent. I don't hear any like clicking or anything, so it seems that no one is just practicing, right? Just do it. Why not? So you have some, you can also create the tables. What's the problem? You don't have internet connection? You have? So what is the problem? You're just not in the mood? Okay, so instructor as I, for example, and then where course instructor ID, which is C here, is I. I don't know really what is the problem here. And let's say if I wanna like select first name. Okay. So as you see, it gives me a table with these 3 columns because I specified only these 3 columns. Of course, you can select the star, which gives you all the columns, right? So if you do that, you can better see like the join of the 2 tables. Now, for example, we join the course and instructor. Whenever you join tables, it adds the columns of like both tables to each other if you select the star, because it's going to select all the columns from the first table, also selecting all the columns from the second table, and then join them, right? So you have course code, course description, room, and instructor ID from the first table, and then instructor ID, first name, last name, rank from the second table, which is the instructor. Okay, so this is how you join 2 tables using where. And as I mentioned, you can write also any like column that you want. If you only, for example, want course code and let's say first name. And the problem was that it in my previous SQL statement that I got error. The problem was that the instructor ID is the same in both tables. I mean, this is the same name, right? Then I had to specify from where I'm selecting them. For example, if I'm writing from course as C and instructor as I, then I have to specify, for example, I that instructor ID. Okay, so this will allow it to understand that it's selecting instructor ID from the instructor table. If I write it C, then it's selected instructor ID from the course table, right? So you could also not using any alias here. So you could just write it as simple as this. In that case, you have to write like this, okay? And then here the same, like course instructor ID is instructor ID. Now it is more clear why I actually, why I was using the alias I and C, because it's shorter and like more readable. So this will give you only these 3 columns, right? And back to the slides. Like join 3 tables, okay? So let's say you want to find the course code, course name, and the student name for each course. Please do not look at the example and try to think yourself, how would you answer this query? And then let me know how do you do that. So first of all, if I want to get course code, course name, and a student name for each course, so how can I, first of all, can I do it with joining two tables? Because we have course code, course name in the course table, and then we have a student name in the student table, right? So why I couldn't just join course with the student? Going to go here. Yeah, they don't have a common field. Like select star from a student, so you can see what we have in the student table, and then select a star from course. So if you see here, we have a student ID, first name, last name, major, advisor ID, and then we in the course table we have course code, course description, room, and instructor ID. Now the problem is, even though we only want to get in a student ID, first name, right? So we want to just get a course code, course name, and a student name. So course code, this is course name, and a student name. And these three columns are in just these two tables. But because these two tables do not have any common field, we need more than two tables to join, right? So let me show you other tables that we have here. Select star from, for example, instructor and enrollment. Now, in the instructor table, again, we have instructor information that is not useful for us, but in the enrollment table, we have a student number, course code, and grade, right? So here, that enrollment table can help us get what we want, right? So because it has a common field with both course and a student table. So if we join these three tables, that is the course table, a student table, and enrollment, it means that we have access to all columns in these three tables, which include the columns that we are interested in, that are student name, a student name, which is in the student table, course code, and course name, which is in the course table. So the goal of this table, if you remember in the data modeling, this was our associative entity, right? And we said we need associative entity to relate two tables, right? Where they have like many-to-many relationship. Because we couldn't have many-to-many relationship, we couldn't design our database having many-to-many relationship with only like two tables and don't using an associative entity, right? Because otherwise, we could have violated the integrity controls in like both tables. Because each student can enroll in many courses, and then again for each course we have many students enrolled in those courses. So we said we need to have associative entity to break it down into two one-to-many relationship. So now you have to better realize how this enrollment table here helps, how this associative entity helps. If we didn't have this, how could we join the tables, right? We couldn't. Now, you can, so this, we are not actually interested in any column from the enrollment table. This is just to help us to join the other two tables that we want. So if you see, you select the columns that you want from these three tables. Then you also have to like link the tables together. Again, if you remember the relational models, so you have, if you, for example, in your exam, you didn't know which ones you have to write in the where, don't get confused, just draw this for yourself. You say, okay, this is a student, this is course, and this is enrollment, right? So when you're writing your where clause, right, first of all, you have to join these two together, right? Enrollment and student. And then you have and. Another join is between enrollment and course, right? So don't write where, for example, you cannot like join a student directly. So you want to join a student with enrollment and course with enrollment. So where course, for example, course code is equal to enrollment course code. So that is the foreign key in the enrollment table referring to the course code. And now you want to like do the second join on the other tables. So and a student ID is equal to enrollment student ID. So a student ID in enrollment again was a foreign key referring to the student table. So this way we get all the columns that we want. We also link the tables together, and so now we can get the result that we want. So this order by is just optional, for example, or if in the question asking you, for example, sort by course code and a student name, then you have to write order by course code and student name. Or maybe I ask you sort the result based on, for example, I don't know, grades in descending order, right? Then you also have to specify grade. You also have to select grade, and then your order by, you have to write order by grade, for example, in descending order, right? Is this clear? Your faces doesn't really look clear to me. So let's see it again together. So we have course code, and what else do we have here? Course description. Now, as I said, if you write the from first and then write the columns that you want, the good thing is that it gives you suggestion here if you write it in a wrong way. And so we want to select these columns and also a student, let's say ID, for example, from course and a student, but we also had to add the enrollment table because these two tables had many-to-many relationship. They didn't have a direct link themselves, but they were like linked through the enrollment table. That is why we added this. Where, first of all, course code is the same as enrollment course code, right? And also a student equal to enrollment a student ID or a student number. And as you see, maybe the foreign key, you use a different name for the foreign key that is referencing to a column. Like for example, a student number here referring to a student ID in the student table, but they are basically the same thing, right? So you could also use a student ID as when you were identifying or when you were creating your tables. So I just wanted to see like both examples having the foreign keys with the same name, like the course code, and also with a different name like a student ID and a student name. So if you write this, let me first show you with the, and also I have to specify the name of the table here. So let's say, for example, course code here, because course code is also exists in the enrollment table. That is why you have to specify. Course description is only in the course, so you don't have to specify. If you do, doesn't matter. And a student ID, I think, again, you have to identify, for example, a student ID, and then we're fine. Now, you will get course code, description, and a student ID. And then maybe you also want to get enrollment grade. Right? In this way, you can see, for example, what was the grade of each student in each course. And now let's order by the result, sort the result by grade in descending order. Okay? If you don't write anything, it's ascending, so you will see grade like this. And I could write grade directly without specifying enrollment.grade. Why? Because the grade column only exists in the enrollment, so we don't have to specify. If you do, it doesn't matter. You won't get any error, but it's just not necessary. But here, for example, we had to specify because we have the course code not only in the course table, but also in the enrollment table. So we have to specify from which table we want to select. So that is the only reason. Now you see the grades in ascending order. If you want to see, for example, in descending, then you can just write this. Now, if the same column name is used in two tables, we should specify which table it is from, right? Now you can also join 4 tables. You can like continue until you want, like joining more and more tables, because it depends on which column that you want to select from. What is the relationship between tables, right? For instance, here we want to find course code, course name, and a student name for each course that is taught by Mona, for example. So we need the instructor name, right? Because Mona is instructor name, which is, for example, in the instructor table. We need the course code and course name, which are in the course table. And we also want a student name, which is in the student table. So why do I need to join 4 tables instead of 3? Because the column that we want are like they exist in 3 tables. Why do we need to join 4 tables? This is similar to what I explained for joining 3 tables. Again, right? Because a student, right? For example, we have here a student, course, instructor, enrollment, and some of them have like many-to-many relationships. So you probably start with joining 3 tables first, and then you see you cannot. Then you will say, okay, I also have to use the enrollment table to be able to join all of these. So you want to get course code, course name, a student name from the course, a student, instructor. So this is probably you will write first, and then you want to join the tables. So first of all, you have to join the course and the student. You cannot, then you will lead to using the enrollment table, right? That is how you will, for example, in exam, you can realize that you have to use, for example, another table. Because here, we want to like have course, for example, using course and link it to the student table, right? Because we want to find, for example, let's say grade for each student on each course. Now, each student and course, so you have to join them, right? Course is in the course information is in the course table, a student information is in the student table, but you cannot join them because they do not have any common field unless you use the enrollment table, which was an associative entity, right? So you can then write all the joins, for example, joining course with enrollment, and then enrollment with a student. This way you join course with a student. And then course and instructor, you could directly join these 2 tables because they have a common field, right? Their common field is instructor ID. Then course instructor ID is equal to, for example, instructor ID. In our example, I think I use advisor ID for one of them. And then you can, again, any other condition that you have, for example, you add and, because you already, I said, whenever you have any condition, you can use the where clause, put all conditions there. Because you already used where here, so you can just add your condition at the end of like the joining, right? So, and instructor name is Mona. And, or for example, maybe you want to get the students with like grade, like greater than something, then you write, for example, and for example, grade greater than something. And always remember, I suggest you to use like this way in your select and where clause, because like especially in large tables, you may not really know which are like the exact same columns in like all the tables. So you're better off going like specifying the names like these. For example, if you are selecting from course, enroll, student, instructor, then just write from, for example, select course code, or you like using alias, for example, the way that I did here. So you can use, for example, course as C, a student as S, enrollment as E, right? And then here you write, for example, like this. It's just easier and faster. And then see course code. So I would recommend you to do it for all the columns. And what else? Now I'll let you go. So joining tables with different links. So I said sometimes we can join tables with a column that is not a foreign key, because sometimes tables can have more than one common attribute. For instance, if you see the staff and organization tables, what are the common fields between like these two tables? One common field is always the foreign key, which is the department number, right? But they also had another common attribute, which is the manager here. So the manager is actually the manager ID. So it wasn't like really good name that I selected. So this is manager ID. Manager ID is actually the same as a staff ID. So this is for the managers, right? And so you see some people have like the manager role here, and their manager ID is the same as a staff ID. So these two columns are actually the same thing, or is a common attribute here. Now you can join staff and organization based on department number, which is a common field and is also a foreign key, but you can also join them based on manager and staff ID, which is another common attribute. So this is what was explaining in this slide here. And this is just one more example from using the staff and organization table. For example, let's say you want to find people with job type as manager in each department, in each division, okay? So first of all, let's see which column you want to retrieve. What are the columns that you want to select? So first of all, we want to find people, right? Which table? Staff, organization, which one has the staff or like the people? A staff table, right? So in your from, you want to write the staff, and in your select, you want to write, for example, a staff name, which gives you the name of the employees. You also want to find job type as manager. So where can we find the job type? So if you look at the tables here, where can we find the type of the job? Here in the staff table, right? Here you can see whether they are in manager role or sales or any other role. Now, we also want to find in each department, in each division. So we also want department information. Up to here, everything is in the staff table. But the problem is also in the division. We don't have division in the staff table. You see, division is in the organization table. So we have to join these two tables because the column that we want to retrieve is in more than one table. So how can you join them based on what we have learned? You can simply use where clause. So you select the column that you want, which is staff name, for example, job, right? Department number and division. So these are the columns that you want to select, and you want to select them from like these two tables, staff and organization. You also want to join them using where, which means where, like linking them through the foreign keys, like this, right? Staff department number is equal to organization department number. And also you want to, your condition is that the job should be manager. Because if you just write this, then it gives you all the job types, sales and everything. But you want another condition that the job is manager. And then you can order by, maybe I asked you in the exam, maybe not. If I ask you, then you also have to order by, for example, if I ask order by division and department name, then you write like this. And do you have any questions? No? So please, if you have not created these tables already, do it. So next session come prepared so that we can like practice these together faster.